Hello, and welcome to episode number 73 already of Let's Make It. And if you were looking for us last week, you probably realized that we weren't on last week because we had a little bit of a sickness. You can hear my voice. I got something and I just wasn't feeling good, so we didn't do a show. And this week, I think I mentioned this last week, I was going to talk about the Arduino Yun, that's this whole show is going to be about just that one Arduino, because it actually is a pretty incredible Arduino. There's a lot of things to show, so it's going to take up a whole show for that. And next week, we have some announcements for you. Some things are going to be changing, especially into the new year, and we want to make sure you're all up to date on all the changes that are going on. So that'll be next week. And also next week, we're going to talk about the doggy button that I built for my dog. I have it working. She's learning it, not necessarily that accurate with it, but we'll talk about all that stuff next week as well. So again, this is Let's Make It, and this is the show where we go through and we make things with Arduinos and all kinds of electronic things, and we show you the code and everything that we did to make it work. And that's what we do every week, and we are starting to expand out into different kinds of CPUs and things like that. And we're doing other little projects on the side, and we're going to talk about that all as well. But this week, I want to take a look at an Arduino called the Yun, Y-U-N. I got an email from somebody asking me about it, and I had never played with it before, so I got one. And after I got it, I'm like, well, this is pretty cool because all the things that are built into it. And we're going to walk through that because it's very unique in how it works, and it has some really cool features. And I actually have some projects already that I was going to do using a regular Arduino and some other stuff. This is going to replace it and do it all on one board. So let's real quickly get started and go over and hop in and take a look at that board real quick. All right, so there's the board. Let me get rid of my lower third here. There we go. So this is the Arduino Yun, and it's unique in a couple ways. First of all, it is the same chip that is on the Leonardo. So do you see that chip right there? There's the same chip that the Leonardo uses. But you'll notice this other area over here. And this area is the same chip that's been in a lot of routers. If you've ever heard of OpenWRT, you have probably used a chip like this. And the chip is designed for wireless routers, or routers in general, not necessarily wireless routers. In this particular case, it actually has a wireless ability, plus it also has built-in Ethernet ability. Now, a couple other things you're going to notice about this is on this end, right here, on the back side, right here, we have a micro SD card. So this has built-in micro SD, in addition to the built-in Ethernet and the USB that you see right there. One of the things you're going to notice is missing, though, is the power plug, because it is powered by USB. You can put in 5 volts into here, but like any Arduino, if you do it that way, if you go above 5 volts, you're going to ruin the board. So it's recommended that you go in through this 5 volt USB. However, even with the 5 volt USB, there's still not a voltage regulator, so it's still easily blow upable because there's no protection on that. So that's a couple of the obvious differences. Now, you would think, since it has the micro SD and the Ethernet, it would be connected like the typical serial or SPI interface to Ethernet into the micro SD, but you'd be wrong. Those are actually connected to the chip that's in here. Now, it's running the chip is an Atheros AR9331, and it's running OpenWRT, but it's a specialized version of it called OpenWRT-Yun, Y-U-N, and it has on it other things as well. It has Python already installed on it, and we're going to show you how you can access Python. It has a few other things too. We're going to show you. Let's see, what's the other thing? Lua. It has Lua on there. We're going to show you a Lua script that you can run to get time and stuff like that. So there's a whole bunch of things that are built into this little Unix thing that's really nice. Now the question comes is, how do they communicate? And that's where we're going to talk about that a lot tonight too, because they do have a library to communicate between them, and it's actually pretty easy to use. There are a few things you got to do differently whenever you want to, well, I don't want to say this. When you want to communicate via serial, you just can't communicate via serial because they're communicating over the same serial lines. So they have built-in utilities to do this using this library. But the other thing is you can program this without plugging it directly in. Right now, you notice I haven't plugged into this brick right here for power. So this is just an Anchor power supply, 40-watt Anchor USB power supply, and it's plugged into the Yun. I have nothing else plugged into it. That's the whole thing right there. And I'm going to show you I can program it over the air as long as it's on Wi-Fi. So that's one of the things we're going to talk about is doing that. So it's a very interesting board because it has built-in Wi-Fi. It has a lot of other possibilities. Now you see these lights up here, and the lights. Let me just get it up on the screen here so I can see what they really are. They are serial receive, serial transmit, pin 13, which is the red one that's on right now. And then there's the WAN, there's a power indicator, a WLAN, a Wi-Fi indicator, and a USB, the white being the Wi-Fi, or the WLAN. And there's 3 reset buttons too, which is also interesting. There is a reset button right here, and that is for the Lineo, which is what they're calling this operating system right here, to reboot that. There's a Wi-Fi reset button right here, and then the traditional Arduino one is on this side over here. The button right there is a reset for that. So there's 3 different reset buttons, and the Wi-Fi reset button is used if you go somewhere and you can't get it on Wi-Fi, because by default out of the box this will be an access point. So you'll see it show up as your wireless networks whenever you first plug it in, and that's how you can get into it and configure it to change all of its settings. But I have it configured right now on my network here, and we'll walk through that as well. So it's no longer broadcasting out that access point information, and it's on my Wi-Fi, same Wi-Fi as my laptop is on, where I'm going to send it to the screen. So overall, it's a very neat board. It has a lot of possibilities with it, and for the price, it's kind of hard to beat. So what I want to do is I want to hop over and I want to show you some stuff on the computer side, and then we're going to program it remotely, and then we're going to go through different sketches and how to use it and some other examples. So let me first hop over to the computer. Okay, before I go too far, I do want to, let me get rid of this little thing out of the way here. I do want to show you that there's a really good webpage on Arduino.cc about this whole thing. This is where I'm going through, because I didn't want to give you all the wrong information about the different processes that are in here. But you can get down through here and you can see the layout of the board. I mean, basically the pin layout is exactly the same as the other boards. I mean, it pretty much uses the version 2 pin layout, and you can see that up here mentions about it has the 332U, which is the same one that's included in the Leonardo. So, and here they talk about the little differences. You can see Ethernet is built into it, programmable, the micro USB for programming and power. And there's also a USB host port, which I haven't figured out exactly what to do with that yet, as far as what would it be useful for. But I have seen some examples of people trying to use it with a camera possibly, and I'm still investigating that one. So let's see. Talk about web services. So there's a bunch of other things they built into it, and I'm gonna walk through this stuff here in a little more detail as well. So you will have to go through it real fast. But and then there's like the reset buttons and things like that. So let's real quick. Let's log into the Arduino. So it's on my network at 118. And when you get to it, you're going to get a password. And there's a default password of Arduino. I've changed it just out of habit, I guess, more than anything. But once you log in, you get a very simple interface to start out. This is basically what it's set to, and this is connected via DHCP on my network. So it gets what it was given. But if you want to configure it, you can come into configure. And you can change the name of it. You can change the password like I just used to log into it. And then here's where you set up your wireless. I have it set up for my one network here, and it's configured to configure a wireless network. If you uncheck this, it will become an access point. So that's how you make it an access point. And then, but anytime you make a configuration change in the wireless or the name information, you got to configure and you got to restart. And then the way you access the actual Arduino code is through a REST API, and you can protect that. So you can, I'm going to show it to you open, no password required. But if it's in the public, you probably, even if it's not in public, you still might want to think about protecting it with a password, which will make the calling device to it have to have a password to do anything with it. But we can go one step farther. If you go into this advanced configuration panel, it's called Lucy. This is, if you use WRT, OpenWRT, this will be very familiar to you. This is basically the same thing. So here's your overview. You can see your DHCP information. Now we don't have any license set up because we're not running as an access point, which we could though. And then associated stations, this would be more if you had it as an access point as well. And then you can go through your firewall. And again, we're just in the status right now. So there's a firewall built into it. You can go through and see all the firewall rules and what's getting hit. Your routes for your network. There's a system log. And as you can see, the Unix system log. There's a kernel log. This is also a Unix kernel log. You can see what processes are running. There we go. So these are all the Unix processes that are currently running, and you can terminate them or kill them, whatever you want to do to them, or you can do it from the command line, which I'm going to show you next anyways. And there's also graphs. So you can come in and you can look at your load on the device. So give it a few seconds and it will load up data. You can see right there, it's loading up data now. And you can come in and look at your traffic, so you can see how much traffic is going to it. And then there's Ethernet 1 is really your physical Ethernet port. I don't know what Ethernet 0 is, but it's not Ethernet. Ethernet 1 is the physical. And then you have your wireless LAN. And you see traffic right there. You're in and out of your traffic. Here's wireless details. So you can see the signal to noise ratio and the strength and all that stuff right here. If you scroll down, you see the data rate, which is very similar to what we just looked at over in traffic. And then connections, which we don't really have any active connections. I guess we do. Yeah, so this is connections to the network, which I am one of those right now looking at this. You can see right here, I'm on port 80. And my device, my laptop must be 101, because right there you see it's 101 talking to it. And then you come over here and you have system set up. And again, here's the host name, which you can set easily on the other page. You can enable NTP so it has the right time. You can have it be an NTP server as well. And it'll pull from these NTP servers right here. You can set up logging in the language. Under administration, you can change your password. You can set up your interfaces. You can say, I'd only want SSH to be active on one of the interfaces, and not the other. In my case, I have it on unspecified, which means it listens on all of them because I'm only using the wireless LAN anyways. And I want it's LF port 22. You don't have to be in port 22, but that is the standard SSH port. Do you want to allow password authentication, and you want to allow root to log in with a password? Typically, letting root log in with a password is not a safe thing to do, but in my case, I'm running on my own network. I don't feel like creating a user just for a demonstration, so I said, yes, you can do that. And if you wanted to use keys versus logins, you can create your SSH keys down here. And then we come into software. And in software, you can see all the different packages that have been installed. And if you want, you can install packages right here. You can delete packages down here. And here's also an available list of packages that you could install. So not all the packages are installed, but you can install packages. Now you got to remember you're on a limited device. But it looks like I have 90% free space, which isn't much, 6.44 megabytes. However, if you use an SD card, that all changes. So then we can go to startup. And so this is what's going to run during startup. So if you have something you wrote on the actual WRT interface or the Unix side of it, you can have it start up automatically. And you can see these are all things that came with it. Here's Lucy and things like that. So. And then we can also do schedule task, which if you're familiar with Unix is cron. So here's your cron tab, which you can define right here. And then there's mount points. So you have all these different things you can do that's Unix related at this point. There's LED configuration, which really isn't used on this board as far as I can tell. I haven't really tried. Let's see. I haven't tried on this. Oh, maybe. looks like I can try all the different LEDs and stuff. So yeah, interesting. I haven't tried that yet. And then you can back up and flash new firmware as it comes out. And of course, here's reboot. And then the last thing here is network, and allows you to come in and set up your interfaces and your Wi-Fi. Things you could do on the other interface as well, but the other one's very limited in what you can do. This one allows you to do a little bit more. So you can see I'm going through and seeing the same thing. Here's DHCP setup, which I'm not using in this case because I'm actually using my own DHCP inside my network. Host name, static route. Of course, you can go in the firewall, and you can add more rules to the firewall, etc. So you can see if you go to advanced, you're going a lot deeper into the configuration of this Arduino. And you gotta remember, you're only really changing the WRT, the actual Unix side of this board. You're not changing the actual Arduino side of this board. So that's just something to remember there. All right, so now that we've done that, we know it's online because I'm talking to it. I'm going to go ahead and I'm going to hide this. And I'm just going to bring up a simple, well, before I do that, here is how you can do it from the command line. So on my, let me get this a little bigger so you can see it. Let's see, can I zoom in? Let's see, where is it? Bigger. Yeah, let me just keep doing that. Looks like you can see that a little better. All right, so what I'm going to do is I've already done this once to make sure it worked. I'm going to SSH, log in as root, and my device is 10.232.1.118. And if it's the first time, it's going to ask you if you want to accept the key. So I've already done that, but I'm going to now log in. And you see I'm in the Arduino now. So if I want to see what's running, I can just type in PS. And there's very few options. In typical Unix, you do PS, you want to show all in the extended view. And you see that it's not an option. The only option you have is W in here. And all W does, so if I do PS again, and a PSW, it's just a wider view. You see things wrap down to the next line. But just like Unix, you can do kills or whatever you want to do as far as that. Just it's a lot more limited command set because it's much smaller. But I can get in here and I can look at the size of the disk, which is not really a disk, it's memory. But if there's a memory card mounted and that kind of stuff, I can see all that stuff like I would do normally. I could reboot in here. I can do coding in here. I don't know if VI exists. VI does exist. So yeah, there's even editors and things in here. So you actually can do editing. And I'm now in the root. So let's see what we have here. So it looks pretty typical for a Unix box. And you can do that through SSH. So if you're familiar with Unix and you're comfortable with it, there's another way you can get in. You can admin it from inside here as well. All right. So what I want to do is I want to go to Blink, which we all know what Blink is. So let me make this bigger too. All right, so basically Blink is the one that comes with Arduino. In fact, everything I'm going to show you today is actually from the Arduino site. And I've made a few modifications to it, but not enough that would confuse anything. So all Blink does is it turns on, it takes pin 13, makes an output, and it takes 13 and goes high and low every second. Really simple thing to do. Here's the unique thing though. So I'm going to go to Tools, I'm going to select my board, Arduino Yun. Now, here's something else I should mention in the beginning. This version of Arduino is the beta version of Arduino. So I'm actually running version 158. If you don't have 158, this isn't going to work like this. So let me get out of 158 or get out of that. And then we go to Tools, and I'm going to select my port. Well, you notice I have a different thing down at the bottom. It says Arduino at 10.232.1.118 Arduino Yun. Well, that's what I'm going to do. I'm going to select that. So before I go and just push this out there, let me show you what the board looks like. Whoops, wrong one. So the board right now is currently not blinking. The red light is the pin 13 right there. So let's go back over to the PC, and I'm going to come up here and I'm going to go and just push this out, upload it. So you see it's compiling. Uploading. Do, 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 do. Yeah, you don't want me singing. And we come back over here now, and our sketch is uploaded. And I'm still only connecting to the power. So that is one of the cool things about this. You could have this installed somewhere, doing an Internet of Things type of function somewhere in your house, and you can just upload your new code to it remotely. So that's very neat. Now the other thing, and let me go in here and I'm going to go back to the computer real quick, and I am going to modify this. Well, not this one. I'll get out of this one. Let me find the other one that I've already done this with. Yeah, let's do this one. All right, I'll make this one bigger too. 24. All right, so we're going to do the same similar thing. We're going to do we're going to turn off and on the LED remotely. So part of this library, first of all, is a console.h you got to include, and that is part of what the Arduino Yun uses to send out its console data or its serial out data. They call it console instead of serial here because it's actually going through from the Arduino into the WRT system and then out to your desktop here. So we're going to walk through this here in a second, but let me real quickly show you. I'll go ahead and I'm going to upload this. Oops. And here we go again, uploading. So what I want to demonstrate is that the serial monitor also works remotely, just like uploading it does. So I'm going to go to Tools. I'm going to bring up Serial Monitor. You're connected to the console. So now what I want to do is I want to go, where's it at? And I want to go to this address, and I'm going to walk through this sketch in a second. So 118, and I'm going to do turn off pin 13. Well, maybe I won't. Oh, okay. I won't, because I'm not quite there yet. All right, let's look at the sketch to make sure I got the right one. I might have picked up the wrong one here. Oh yeah, H and L. Okay, so I am now connected. This is a two-way demonstration of the console. So like when you normally connect via serial, you can send data in and you can get data out. So I'm going to send it an H. LED turned on. I'm going to send it an L. LED turned off. And if we go back over and we look, if I send it an H, like now, and I send it an L now, there you go. So I'm controlling this. Let's walk through the code. I'm going to demonstrate this a little bit. So what we have here is down through setup, we do bridge. Bridge basically is what the communication is between the two different chips. Now we wouldn't really have to use bridge. There's something in here I'm going to kind of show you this, but then console is what we're using to communicate back to my laptop. And what we do is we start up console, and like serial, you got to kind of wait until it's ready. And then that's when it comes back and says you're connected to the console. We set up the LED pin as an output, and then we're going to loop. And what we're going to look for is data incoming from the console. So if there's data incoming, I'm going to read it. And if it's capital H, I'm going to set the pin high, and then I'm going to print to the console LED on. And the same thing goes for L for low, and then I'm going to wait 100 milliseconds and do it all over again. So this is how we can, instead of using the serial, you use console. And it basically does the exact same thing, and it does it over the network. You do have to be on the same network. In my case, the Wi-Fi is on the same network that my laptop is plugged into. So we are on the same network, and that's all that's required. It makes it a very nice way of managing and debugging your application, especially if you already have it installed somewhere and you don't want to go take it off the wall and bring it down and reprogram it. Also, you can just do it all, over Ethernet. And you can have multiples of these around and just pick the one you really want to use. So that was what I want to demonstrate with the console. All right, you don't have to save this. So let's go back over here and look at the next sketch that I have ready to go. And this one is a demonstration of, well, before I do this, I need to plug it into my laptop. So I'm going to do this. I'm going to go and unplug it from the power. And I'm going to plug it into my laptop because now I'm actually going to use the serial for this one. Just to kind of demonstrate that it works both ways. All right, so I got it plugged into serial now, and let's let it get booted back up. And what I want to do is while I'm in here, I want to go change my port to the there we go. USB modem. All right, so what I want to do now is I want to okay, well here's another thing that's a little different. In normally when you plug in something or you can bring up the serial monitor, it reboots itself. With this board, it does not, because you're no longer talking to that same chip. You're actually talking to or are you? We'll find out. We'll find out. I don't think it's the case. I think in my example it didn't work quite like that. So let's go ahead and upload. All right, and then let's go in and look at the serial monitor. Oh, maybe it did. Okay, so let's go look at what this does. That is what came back from a web page. What happens is when we come in, we have process.h. So what process.h does is it allows you access to the kernel in the Unix side of the board. So when you come down here, you start your bridge up. And again, I'm doing serial instead of console right here. And I'm going to wait for the serial to come up. And then I'm going to run this one command called run curl. Well, if you're familiar with Unix, inside of Unix there's a little program called curl. And what curl does is it goes and it downloads a website in text form. So that's all we're going to do here. So we come down here to run curl. We create a process called P, and then we begin the process and we call it curl. So anything that's in Unix, on the Unix side, you can run by doing the begin. And we're going to show that to you in a couple other ways here as well. And then we're going to add the parameter. So the parameter that curl needs is where do I go to get it. So we're going to give it arduino.cc.ascii logo.text. And that's what we just downloaded. And then we're going to tell it to run. And then we come down here, and while there's data available in P, we're going to sit here and go through this while loop. We're going to keep reading one character at a time. We're going to print out to the serial port each character one at a time. And then after all of the data is out, we're going to flush the serial port, make sure that it's all out, just to make sure. And then we're done. That's all we're going to do is do that one thing. And we can easily demonstrate that. Let's go back over here to the serial monitor. Well, maybe not. Like I said, I don't think it resets it. We're going to try here real quick. It does not. So let's do this. We're going to take this run curl. And we're going to move it down here to where it says nothing to do. Just like that. Then we're going to delay. We'll do every 10 seconds. No reason to pull it down every 5 seconds. Let's re-upload this. Let's go back to the serial monitor. Okay, there you see it pulled down twice, and then in 10 seconds it's going to do it again. So basically you're sitting there and you're pulling down a graphic or a text-based graphic from the website. There it is again, Arduino. So this is a good example of how you can access the Unix side of this board. All right, so let's go ahead and get out of this sketch. And no, I don't need to save this one either. And let's go to the next one here. Okay, so this is the one I was trying to demonstrate a second ago. This is a lot more detailed of a bring it up and make this bigger here, of a web-based application. So that's why you're going to see this goes a little bit more in depth. So we need bridge because we need to communicate between the two. But we also want to run basically a web server. Now the Unix side of the board gets involved. So it really is the web server itself, but then it sends over to the Arduino chip to what was requested, and then this returns back the right answer. So you're not really ever talking to this Arduino chip itself. You're only talking to the web side, which is under Unix. So what we need to do is we're going to be a client and a server in this case. So we need a Yun server and a Yun client. We define our server right here, and then we're going to do serial again, and we're going to start up 9600. Pin mode 13. We're going to set it to output, and we're going to set it low because sometimes bridge takes a little while to start. So this is a good way to tell if it's actually ready or not. And then we're going to set it high, saying that we're ready. So then we're going to tell the server, listen on localhost right here. And then we're going to tell the server to begin. So we get to loop. We tell the server that we're going to define a variable called client. It's a Yun client. And we want to accept anything that's at the server. Well, if it comes back with a connection, we're going to process it here. And then we're going to stop the client, and we're going to wait for 50 milliseconds and wait for the next connection. Well, let's say we come through here and we finally get somebody that connects. And so we're going to go to the process. And what we're going to do in process is we're going to look and see what they wanted to do. So the command is either digital, analog, or mode. And here's how we put that into, let me bring up this. So right here you see this is the address. So then it's /Arduino. Everything is always /Arduino if you're going to communicate to the Arduino. And then I'm setting the command digital. So that's what I'm looking for over here. Is it digital, analog, or mode? And then I'm going to call the subroutines based on what it is. So let's go just walk through digital real quick, and then we're going to run it, and we'll show you what the options are. So we call digital command with the client, and we're going to have two variables here, pin and value. So we need to know, like, say pin 13 is high or low, or 0 or 1. So what I do is I do the client and I do a parse int, which brings me back the number, the first number. And then if I check to see what the next thing is, and if it's a slash, I know I'm going to set the value. Where if there's no slash, I just want to know what the value is. So if there's a slash, I'm going to read again, doing parse int from the client, the next value. So now I have both the pin and the value. So I'm going to do a digital write pin and value. If there wasn't a backslash there or a slash there, I just want to get the value. So all I'm going to do is just do a digital read, and then I'm going to send back using the client that pin D and the number pin D like 13 is set to, and then the value that it's set to. So and then here's something we're not going to really cover in great detail, but the bridge function itself has the ability to store in the Unix side, kind of like in a temporary memory, values. So, and there are key value pairs. So it's one of those things where if you need to store something temporary, but you don't want to do it like in a local variable, you could do it here. It's just another way of doing it. It's not something that's not permanent. So if you turn it off, if you restart the Arduino chip itself, it's still there. But if you restart the WRT chip, it's gone. So you can't rely on it for being like something like an EEPROM. So this is an example of how you could do it. So, but anyways, that's our digital write. So what I want to do is I want to upload this real quick, and then we're going to watch what it does. All right, so we're done uploading. So let's go back to the web browser, and we're just going to do a quick demonstration of what happens here. So right here, I'm going to do the address /Arduino/digital/13, and I'm going to get rid of the slash in the value, and it's going to come back and it's going to tell me pin D13 is set to 1, which means D13 is on. Is it? It is. You see the red light? It's on. So this time I'm going to come back and I'm going to say 13/0. and it's going to come back, and it's going to say it's set to 0. Well, if we go look, it's off. So if I set it to 13/1, and we go look, it's on. So let me set it back to 0, and you'll see what happens. I mean, it really does work. 13/0, and I'm pressing enter now. It's that fast. So when we come back here, we can look at all the different pins. I can go back and look at pin 12 if I wanted to. And pin 12, set to 0. Nothing's on pin 12, so it doesn't really matter. But this also works the same way. If you go into analog, into the code, look at analog, here's an analog command. And it does the exact same thing. We can set our values or read the values from the analog pins right here, just like we can the digital. The only thing we do differently is instead of digital right here, we do analog. So let's see, I want to do analog 1. A1 reads is a value of 359, and it's just floating, so that's probably why. Let's see what analog 2 reads right now. 277. Again, it's floating. So there was nothing holding it up or down. It's just kind of floating there. Now, we did have another command that we haven't looked at yet. And that is the mode. So is it an input or an output? So what we do here is it basically, there should never be a backslash here. Or, I'm sorry, no, there has to be a backslash there. Otherwise, it doesn't make sense. So what we do is we look at the string mode, and if it's equal to input, we're going to configure the pin as an input pin, or if it's output, it's going to be configured as an output pin. So let's go try that real quick. And we're going to change analog to mode, and we're going to say pin, let's say pin 3, and we're going to set it to output. Pin D3 is configured as output. So there we go. If we would, I think if we leave this off, will it tell us? Nope, just gives me an error. So there you go. I mean, it's so, yeah, I'm just getting a little lost here. Why did it not give me, it should have given me an error other than just error. Or is that what it said in the code? Let's go look, because I don't remember. It should say error invalid mode, but for whatever reason, it's not. All right, well, I don't think I need to take the time to figure out why that is. But yeah, something is definitely a little off there. Because, oh, no, that's right. It just says error. We'll change this just to make sure. Yeah, it's taking me a long time to find it. Something, when you blow up things, there it is. So, semicolon. All right, we'll just make sure that's what's going on here. All right, let's go over and try this again. So now if I just give it this, error, no mode specified. Okay. So the other error that I thought was going to show up was because it didn't have the right invalid mode junk. Okay, good. That's what I was seeing before. All right, so I'm comfortable with what's going on right now. Anyways, that is an interesting way of getting data in or out. So if you had something that was reading temperature, you could, instead of setting the mode, you could just say Arduino/temperature, and it would bring out the temperature, or any of that kind of stuff. So it's real easy to go in and you can just pretty much copy the stuff and change that stuff around. All right, so let me go to the last one that I have here. And this is another shell command that will get time information. So let's go. Oh no, wait. This is the strength of the Wi-Fi signal. Let me bring this, make it bigger. All right, so this is what it's going to do is something very similar to what we've been doing so far. We're going to set up a serial port. We're going to start a bridge. And then, and you see our pin 13 is that telling us when it's ready. And then we're going to wait 2 seconds, and then we're going to do a Wi-Fi check. And the way we do that is, remember I mentioned before that it runs Lua. So here is a Lua script called Pretty Wi-Fi Info, and it will run this command, and everything that comes back in, it's going to output to the serial port. So basically, and it's going to wait 5 seconds and do it again. So we have a process we created called Wi-Fi check. So we create that right there. Then we run the shell command, and it is user bin pretty Wi-Fi info.lua. And then that should come back with the results, and we're going to sit in this loop right here. And while data is available, we're going to read in 1 character at a time. We're going to put it out to the serial port 1 character at a time. Then we're going to put a blank line and wait 5 seconds, and we're going to do it again. So let's upload this real quick. All right, let's go into the serial monitor. Did I go into the serial monitor? I don't see it. There we are. So there's lots of information. About 15 minutes ago, I moved it from the other power supply into my laptop. Its current IP address, net mask, the MAC address, transmit and receive, and signal strength. It's in client mode. It's on the Han network. It's one of our networks here. So yeah, it gives you a lot of information, and you could take and bring that information back, and then parse it. Or let's try something real quick. Let's see. What I want to know is my IP address. So we could do this. Let me make it back to normal size because it's going to be hard to edit otherwise. Now bring it back up. All right, so Lua, and since we're in Unix, we can grep IP. Let's see what that does. All right, we're done uploading. Let's look at the serial monitor. Looky there, you see IP address. So rather than, this is one of the great things about doing this stuff with Unix. Let me bring this so it's bigger and I can show you what we did. If you remember when we were doing this before, we were getting all the data about the Wi-Fi, but you may not want all the data. Maybe you only want your current IP address. So part of Unix is a command called grep, which allows you to search for things and only return lines that have this in it. So basically what I said was grep for IP, and what I get back when I do that is just the line that says IP in it, which is IP address right there. And you can take it a step farther because other things you can do in Unix or Linux that would allow you to use the cut command that would come back with literally just the IP address. And you could do it all based on this one shell command. So I could cut wait looking for the second space and everything after that, and then cut looking for the slash and everything before that, and then I'd come back with my IP address. And you could do it a couple different ways other than cut too. There's other, I'm not sure what languages or shell tools are actually installed. So we'd have to go and check that out. But there's even easier ways to do that. But that's one way of doing it. So we went to this one line where before we had the grep. Actually, why don't I do this? I can't do it when I'm big. Never mind, I won't do it. I was going to say, I'll just take us out real quick, but it's too hard to do when it's big like this. But there's one way of limiting down what you get back. And you could even create a script in the Unix side of it that would do this for you. So you'd basically call one command and bring back what you wanted instead of doing it as a command line here. But I mean, if you know your Unix commands, run shell commands easy enough to call, and you get back what you're looking for. So what that means is this tiny little board, this little board right. Too many buttons right here, and rusty. Can do so much. I mean, because it can run the standard shields and everything like that too. So if you have something you want to get data out or get data sent somewhere, the one thing I didn't talk about is there are some other libraries that are available to use online services. So let me go find them real quick. I think I have them still up here. I found them earlier today. Trying to think what it's called. Tembu. So there's a site called Tembu. And it's designed for the sending things from the internet and Internet of Things type of data up. There's a cost involved with it, so you got to kind of remember that. But let me see. Let's look at pricing and see what the pricing is. But there's a library built in or comes with the Arduino that you can communicate to the service. Let's see, pricing. So here's the, it's like $7 a month if you want to do no more than 25,000 monthly calls. But if you want to do like 100,000 calls, it's $49 a month. So there is a cost involved with it. This actually has, I've actually started another website that I had one for storing the B data. But basically it's just a big database you can just send this data stuff up for. That's kind of what this is, but not exactly the same. Oh, there's a free plan, 250 calls a month though. So that's not very many. Especially if you're doing like temperature sensing once an hour, that's not even, what's that, a week? So no, it's more than that. It's a little over 10 days. So it's less than 2 weeks. But it goes away really quick, especially if you're doing some testing stuff. Anyways, I had this B thing where I was storing all the B data in this flat but flexible database that you can pull data out of in many different ways. And I decided to modify it just slightly and start doing something similar to Tembu. Tembu doesn't do database necessarily. They're a little different than that, but it's similar in concept where the Arduino or whatever could upload to the cloud, and you could get back that data in a bunch of different forms. You could do it as far as graphs over time. You can pull out reports. If you wanted just a current status, like the one of the things I like to do with this, and I'm going to go try, is we've always wanted to do this thing in the garage where we'd have the garage doors up or down, because we sometimes forget to put it down at night, or we left it up for somebody and when they left to the garage and we just didn't put it back down. We also occasionally have a refrigerator out there that it trips not to trip a breaker, but trips the ground fault, and we just don't know it. So I was going to put a sensor out there that we knew all the status of the stuff in the garage, because it's on the other end of the house, and this would be the perfect thing for it. And well, how do I get the data back into some kind of display or some kind of warning? So that's kind of where I'm thinking with this other site. The B thing kind of has the basics of it there, and we're going to expand that out now. And I can just get current, like on-off type status information, true, false, or single values, and I can log it over time if I wanted to. So that's just one of those things where I'm going to make it all open source as well. So it'll be anybody can get to any part of it that they want for no charge. You can download the server and put your own server up if you wanted to, or you can use our server. The libraries for the Arduinos, I'm going to do a Raspberry Pi and a bunch of other things as well. So anyway, that's where we're going to kind of go with that site as well. We'll let you know when it's up. I pretty much copied over the B stuff already, and I've modified it slightly, and it should be pretty close, and it's a good starting point, but it needs to be rewritten a little bit for I'm not using the Arduino to send the data up for the B stuff. I'm actually using a Raspberry Pi, so we do get the right libraries for the Arduino stuff, and again, it'll be all open source, and people will have other platforms they want to write libraries for. We'll definitely encourage that, and it's going to be open up on GitHub, and it'll be all available. All right, so that's it for this week. It took a little longer than I thought it would be, but it's a lot to go over, and I just scratched the surface of it. There's a lot more to this. Like I said, if you go out and search for the Arduino Yun, there's all kinds of examples out there. I just took a couple that would explain the basics of it. but there's so much more to it than it's available. And like I said, we just scratched the surface. I mean, we'll come back to it some other time and go a little bit deeper with it. But that's what I wanted to cover for this week. Like I said, next week, it's a kind of a mishmash of things we want to cover, kind of clean up some things that are kind of hanging out there. And we probably going to have an announcement next week too. I think, well, for me, it's a good one. But it's not a huge big deal, but it's a little bit of a change in how we're going to do the show a little bit. So we'll bring it up next week and let you know what's going on. If you are watching on YouTube, please hit subscribe, share it with your friends, like it, send it out on Twitter, help us get the word out about this show. It still continues to grow even through our little bit of sporadic times here as things are in the midst of like a little bit of change. So definitely if you are watching this kind of randomly, you'd like to get more regular, go to iTunes or any of the other podcast directories and you can subscribe. You can watch us on the Roku. We have a Roku app out there. Our iOS app is, well, first was denied. It's back out there again. We'll see what happens with it. And you can also watch us. Let's see, where else can you watch us? Well, pretty much anywhere you can get podcast. But TiVo, we're on TiVo as well. So yeah, just spread the word around. You can watch it on YouTube or sign up and get a podcast, get it downloaded regularly. That way you don't miss an episode. You can also subscribe on YouTube and you get notified when we put new shows up there as well. All right, everybody. Have a great week and we'll see you next week. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.